domain, right, these are all the first coordinates, remember, your x's. Um, so as you can see here, as I get closer and closer to the origin, this thing approaches 0. So the domain of the log function is everything greater than 0. Now I didn't say greater than or equal to. We don't include 0, but everything greater than 0. Alright, everything greater than 0. And we'd say that the range is going from negative infinity to positive infinity. These are our y values here, even though it's going real slow, to positive infinity. But okay, so as you can see here, we're going to end up having to throw out negative 8 because negative 8's back here, right? There's no graph associated with negative 8. So we got to be careful. We have to look at the domain of our log function, right? The domain of the log function. So let's go back to the whiteboard. Alright, so we're going to throw away this guy, and this here is the only one now that is the solution to this equation here, to our original equation. Alright, and you can always check this. Now you can't, most calculators won't do log base of 4. Let me go down here, we got some room. So we would plug in, well, let me just rewrite it. So we got log base 4 of x is equal to 3, and we said that the solution was x is equal to 8, right? And so we would type this in the calculator. We could say 2 times, we do what's called the change of base formula here, log base x over log base 4, and of course I didn't state this, but this is how I actually graphed it. Actually, I think if you were looking up in the top left corner, you would have seen how it was written out. Okay, so now we can actually put this in our calculator, and we should get, I say approximation here, but if we plugged 8 in right here, we should get pretty close. Alright, let's do that. Alright, well, I just plugged it into the calculator, and of course it's equal to, not equal to 3, I mean 8, it's equal to 3. I just woke up. Alright, so this is how you'd actually type it into the calculator. Alright, let's work a couple more. Okay, so this one's going to be a little bit more difficult. We got log base, I guess I'm still working with log base 4 here, of x minus 3 plus log base 4 of x plus 3 is equal to, we'll say 2. Alright, so what I'm going to do is collapse this down to one single log function. So we got log 4 of x minus 3 times x plus 3. Okay, this is part of the log properties here. And I'm just going to put a bracket saying, hey, look, all that's inside the bracket there. And then we have 2 here. Now we're going to flip over from log form to exponential form. So we have 4, right, squared, and then we write x minus 3 times x plus 3, and of course the log right drops out because we went from logarithmic to exponential. And then what I'm going to do is go ahead and say, okay, let's just make that 16, multiply this out, so we have x squared. Since we have a minus and a plus, this just becomes x squared minus 9. Alright, I'll let you multiply that out and show that it's x squared minus 9. Alright, and then I'm going to take this 16 over. You know, there's a couple ways of doing this actually, but I'm just going to do it this way. And so we have x squared minus, was that 25? And so we can factor that. It's a difference of squares, so we have x minus 5 times x plus 5. And so we set both of our factors equal to 0. And we have x is equal to 5. And then we set our other factor equal to 0. And we have